Okay, welcome to lesson 3 on discrete functions. We're looking at more recursive sequences. So by this point, we've actually seen the Fibonacci sequence. So we're going to look at that as a strategy. We've also seen the arithmetic sequence, and we've also seen one that's kind of like a mix between arithmetic and geometric. And so we'll explore all those again today. We've seen the geometric one too. But the goal for today is actually to create sequences, represent sequences that are recursive, but they're not arithmetic or geometric. And so we're going to look at recursive sequences. The main goal, but the part of this one, so part of this is the algebraic formulas is to look at the arithmetic and geometric ones. But today we're just looking at ones that are not arithmetic or geometric, so they're not going to actually have a general term. So if you can look at this question, determine the recursive formula for the following sequence. You can pause the video and try it for yourself. So you'll notice that we're actually going to be going 3, 6, 12, 24, and so what's happening is we're getting the differences doubling. And so if the differences are doubling, doubling the number, it actually works out nicely. So if we double every number, we get really close to the sequence as a big hint. So our formula starts with t1 equals 4, and then if we notice that tn is just the term before it doubled, but then subtracted 1. And so that'll work for everything. 25 doubled is 50, subtract 1 is 49. The next one, you can try this one and pause the video, write a recursive formula for the following sequence. So you can see we're adding 1, adding 2, adding 3, adding 5, adding 8. And if you recognize that, that's actually the Fibonacci sequence. So the differences are in the form of the Fibonacci sequence. And this is one strategy you're always just going to want to look for. Can I add two numbers before, and is that going to do good things? And so it's close. 3 plus 4 is 7. That's almost 6. 4 plus 6 is 10. That's almost 9. 6 plus 9 is... And the good news is they're always 1 over. And so we can say that t1 is 3, t2 is 4, and then tn is the two numbers before, subtract 1. Another one, so this is just, you have to create the first 5 terms. So one piece of advice here is to not look at subbing in numbers, so not look at subbing in 2 for 2 right here to get the second term. It does work. It says t1 if you sub in 2, and then 2 here. But also just look at tn minus 1 as the term before. And so if we take 2, so if we want to get the second term, we take 2 times the term before it, we get 2 times 3, plus, we need the second term, so we say plus 2 minus 1. So one piece of advice is just to set up a little table of values for yourself. So we know 1 is 3, we know 2 is 7, so 2 times the term before, plus 2 minus 1. The third term is 2 times the term before is 14, plus 3 minus 1 is 16. And then 4 would be 35, and 5 would be 74. So by writing this sequence like this, just allows you to see those n values as well, which you could write in commas as well. Just put the n values on the top or the bottom. Find term 406. So this is sometimes students will read this question and be like, oh, I have no idea how to do that. This is recursive. I don't know how to find a term more than, I'm not going to find every term all the way up to 406. So, or what students will try to sub in 406 and for here, and realize that they get 406 minus 1 is 405. We don't have 405. So with these ones, they're actually called recursive periodic sequences. And so what you have to do is just be patient and start creating this sequence. So term 1 is actually 3. Term 2 is -3. Term 3 is 3. Term 4 is -3. And we notice that we just kind of switch between 3 and -3 such that that every odd number term is positive and every even number term is negative. And so 406 must be -3. Similar idea here. We start writing out the sequence. We have 1, 2, 3. Term n is the term before, which is 3, minus the term before that, which is 2. So 3 minus 2. plus 1, so the next term would actually be 2. And so we just keep doing that. This term minus this term is negative 1, plus this term is positive 1. This term minus this term is negative 1, plus this term is positive 2. And we notice that every even term is 2. So 406 has to be 2. We also notice, like if we're asked for 405, that this goes 1, 2, 3, 2, 1, 2, 3, 2. Once it starts to repeat itself, you probably want to do the 7th term and see the next 3. But 1, 2, 3, 2, 1, 2, 3, 2. Once it starts to repeat itself, then you know it's always going to be 1, 2, 3, 2. So term 400 must be 1, 2, 3, 2. So end in 1, 2, 3, 2. So term 404 must be 1, 2, 3, 2. So term 405 is 1, and term 406 is 2. So it gives you an idea of the pattern. So every 4 terms. So all multiples of 4 will end in 1, 2, 3, 2. Term 401, 402, 403, 404 will be 1, 2, 3. That should be 1, 2, 3, 2. So term 405 is 1, and term 406 is 2. Again, there's a mistake there. That should have been 2. And there's some practice.